Good afternoon, and I'm very actually honored to be here speaking after these prestigious speakers. I want to thank the university director and a special thank to Rita Cucchiara, without whom none of this could have been possible. My name is Frederic Pariente. I'm the deputy director for the NVIDIA AI Technology Center in Europe, and I am here with Giuseppe Fiameni, who will be the lead engineer for Italy, for the Italian collaboration. Let me take a minute to talk about, to introduce NVIDIA. So we are a computing platform company. We pioneered a new form of computing called accelerated computing, where the compute-intensive part of the software execution is sent off to a coprocessor, the GPU, our invention back in 1999, that is a highly parallel processor. And by highly parallel, I'm talking thousands of cores, not tens of cores. We work at the intersection of high-performance computing, computer graphics, and artificial intelligence. We build computing technologies, software and hardware, for the most demanding tasks that traditional computers cannot cope with very well. Very demanding tasks like simulating physics inside a computer, and this is high-performance computing, simulating reality, like in computer games, and simulating human cognition, and this is, of course, artificial intelligence. Increasingly, we are known as the company fueling the AI revolution, and we're very grateful for California University to invest in our technologies. And NVIDIA indeed reignited AI under its latest form known as deep learning, thanks to our GPU, our core technology. Deep learning differs from the traditional machine learning techniques that are based on the manual programming of the features that, for instance, you would seek in an image. You want to recognize something. And that approach was tedious, error-prone, and actually not quite limited in accuracy. Also, every new feature that you wanted to recognize then would require a new specific development. So in AI, we say that it doesn't generalize very well. On the opposite, deep learning relies on the single algorithm, the neural network, that we train with data. And its accuracy only depends on the amount of data and on the choice of the network. So you will have heard or learned here, we are at the university, about CNN, for instance, that are used to do image recognition, or RNN that are used for when you work with time series. The deep neural networks demonstrated human-level accuracy in many tasks, and this is what's created the tremendous interest in this technology. At NVIDIA, ourselves, we've done amazing things with AI. I'm hoping this is going to work. Yes, the videos, you never know if they're going to work. So the GoGAN interactive demo, you sketch on one side, and then the AI automatically generates photorealistic pictures of the sketch. In 3D pose estimation, a single camera looks at an image, can recognize the 3D pose of the person inside that image, and project that 3D pose onto a 3D world. With reinforcement learning, we teach a neural network. A neural network teaches a robot how to stand, walk, and even do backflips. For the Leonardo kitchen robot, so we have one of our research labs is a robotics lab. We created a virtual environment where we teach the robot how to be a robot, and then we download the software into the physical world, into the real hardware, and bingo, the physical robot behaves like in the virtual world. And this ability is critical because you cannot afford to train a robot in the physical world and keep breaking things. With MetaSim, we generate 3D data from synthetic 3D data from 2D data, and this is crucial to speed up the labeling and the learning phase. Another example with semantic segmentation, where you learn from the labeling of each pixels on an image. So here we developed a video prediction methodology to be able to automatically annotate the segmentation. And again, being able to label it and handle, to increase the data set that we need is very important. If you apply segmentation to healthcare, with this 3D segmentation work that we've done, we are able to infer, to recognize organs, and this is much better than just looking at the points from the CT scans, right? And so it's much better to look at the image on the right than to look at a dust of blue points for a doctor. And finally, if you put all this together, then we can train a car, to drive, to position itself in space, to decide what action to make, and we do it in the most redundant and diverse way, because this is how we can ensure safety. Going forward, so today, a lot of the AI has been used to really turn, our phone into smarter phones. But what we anticipate and what we invest in is going from a world of smartphones to a world of smart everything. And really here we're talking about yet another level of smartness, because in a way next to a phone you always have an intelligent person, sitting next to the phone. In the Internet of Things, in the world of IoT, the devices will be autonomous. So you really need them to be smart in perceiving, sensing the world, and then acting on it. Again, no person next to it who is really the smart agent, with the smartphone. For this to happen, 3 revolutions, are needed. So, one, we need reliable AI at the edge. We need those connected devices, and we need next generation wireless networks that can support all this. And those 3 revolutions are actually happening. So, the devices are here, and we're getting to actually hundreds of billions of devices. 5G is coming and is bringing a ultra reliable, low latency network. And then, AI at the edge with, the amazing economic impact that it brings. And edge computing is really needed here, because we cannot grow, 5G will bring an increase of 1,000-fold in terms of bandwidth, and we cannot increase the pipes to the data center 1,000-fold, right? So edge computing will be needed, and also we have some data privacy issue, right? So you might not want to send data back to the data center, right? So this is happening, and a single paradigm, the single edge computing paradigm will actually transform many industries in many areas with huge impacts. Because here the numbers are staggering. We're talking about tens of millions of miles of road in the world, of trillions of kilometers driven per year, 500 million farms, tens of millions of stores and everything. So if AI can help us gain just 1% efficiency on $1 trillion market, this is a huge impact. Of course, NVIDIA is already working there, as I mentioned, and we have the EGX platform with vertical frameworks, and the latest to date is the aerial framework for 5D acceleration that we actually announced at Mobile World Congress very recently in partnership with Ericsson. This is just to put the EGX platform in perspective with the rest of the platforms at NVIDIA. So in the bigger picture, you would have, for bigger devices, we have products in the AGX family inside the car, a big robot, of course, for a very small device, a smart ring or something like this, it will have to be much more passive. So we have AGX product, and then we have DGX for the edge computing, and then all the way to the data center with our traditional product. On top of this, something very important, which is this NGC software repository, so we can deploy all along the whole path, the same software to all of the devices. Some examples of companies that are working with us. Verizon, we work with them in the US, and this is really a smart video analytics scenario to make the street safer. Another example here with a company called SPIL, and this is more like in the industrial inspection example, and we have some, we're adding with deep learning a second stage in the inspection. So first you have the first stage, which is the optical inspection, but then you have a lot of false positive, and you can imagine that with this industry, a false positive or a negative that you let through, it has a huge cost down the road. So we've worked with them, and they have added a second level of expansion, and they got to 100% satisfaction here. And then finally, again, some inspection, but this is in the field, and this is here with drones, spotting for potential hazards and doing predictive, essentially predictive maintenance eventually. NVIDIA and industrial players are not the only one, interested in AI, and AI will actually be at the center of key societal objectives. Our nations, we want to improve the health and the quality of life. We want lifelong education. We want to develop the economy. We want security, and AI will be at the center of all this. And the notion of AI national initiative is very key. And as a matter of fact, every country today understands that that AI is going to be critical, and has worked to put together a strategy for the nation. This is an extract from the US document, but all of those strategy reports actually, they share three common pillars. So first, there's a need for a national infrastructure, a national AI infrastructure. Very similar to what we did for HPC, 30 years ago or plus, or 50 years. I think Chineke was 50 years. So 50 years ago, where at the time, the battle for independence of our nation was, to master the atomic energy, the bomb, those type of things. Today, the new battleground for our independence is really AI. Right? So we need to replicate what we've done for HPC for AI. So, first pillar, the infrastructure. The second pillar, of course, industry solution application focused on those societal drivers, to improve our society objective. Again, health, education, and security, and so on. And then finally, and that was already mentioned in the previous talk, is upskilling the workforce. There was the mention about there's those new startups and new use cases, but what about the existing businesses, the existing people, and how do you bring them into the new world of AI, with AI being a general purpose technology? So those three, we've looked at those documents, and they share those three pillars. In Europe, we have a fourth pillar that we care a lot about, which is ethics and data privacy. And this has an unintended consequences, that it is slowing down a little bit the experimentation in Europe. And when we look at what is being done in Asia or closer, in Middle East, but really Asia is, I would say, 2 years ahead of us in terms of experimenting. We can also look at the angle of startups, and you would spot very quickly who are the big players, the USA and China. Another interesting data point is those were the most well-funded companies, and the top 2 here are Chinese companies. So China is, I will take a couple of examples here to show how the nations are rolling out their AI national program, and I will take them in Asia again because they're sort of ahead of us. And I will start with China, which is probably the next leader in AI. And China has really a holistic plan to go to become an AI superpower. And it also has a powerful central government to be able to actually implement this. And China is not afraid of actually disrupting the current state of the affairs. So a lot of the China wealth has been built on a wide access to cheap labor, and they're not afraid of targeting this and to automate the industry in the country. Some more details about what they want to do. Again, it's a really holistic plan, and the 2 things that I think that really struck me when I was looking at the data about China. One is this fact that they're really investing massively in automating the industry. Again, this is a disruption for them where they have a lot of labor, and then they've invested 5 times more over the past 5 years than Europe in bringing robots. So that was one aspect, and then the second aspect I'll come to it later is on the education side of things. So it shows some data point about how much robots are being deployed in the industry. Even in China is very well known for dumplings, and even in an industry that is let's say non-tech industry, they are investing with robotization and AI to replace this very labor-intensive task. So before you had the old way of making dumplings, and then now you have the modern way of doing dumplings. As a result of all this, then now China is the country with the most automation in an industry by far with respect to the rest of the world. I'll skip some other example. Of course, you would expect all the traditional use cases also being deployed in China. Lots of experimentation on more traditional computer vision use cases. So, and I want to quickly go to here in agriculture, for self-driving car. So I think this is the second interesting data point about China is that they're making a huge investment in education, because of course if you are replacing the worker with AI and robot, then you have to really invest big in upscaling the workforce. And what this is showing is that China, with the growth in GDP, has been able to maintain a 4% investment in education, despite the big increase in the GDP. And AI is going to be central in teaching AI, but also using AI as a tool to teach the masses. So this is going to be very important, because when you have to teach hundreds of millions of people, how do you do it? So there are a lot of use cases, a lot of startups that are actually working in that space and on online education, because this is how you're going to reach the masses in China. Online education, AI-powered, because again, you cannot have an English teacher, for instance, listening to every person that is repeating to see if their accent is good enough, right? So those are the some of the examples that showing the convergence of both the online education and the AI education in China. I have a slide here. I think there was so some of the startups that we're working with in China on this use case that is very important, which is the English voice assessment, right? Teaching English to everybody and have an AI, helping you rehearse and so on. And then you have a bunch of other examples. As a result of really focusing on the education, of course, this has result on the result of academia and their success in publishing and so on. And this is a statistics of what are the countries that are leading in research publications that are mentioning deep learning or deep neural network, and you see that China has surpassed the US here already. So it's not only in terms of volume, but it's also in terms of quality. So not only they are publishing more, but they're also increasing their share in the most referenced, the top papers, right? So you see the trend, and China is really, on a trajectory to go and surpass the US. This is just another viewpoint, not the publication, but the patents, and again, very strong in the patent. So here, of course, you have to be a little bit careful, because in patent you have different, let's say, categories of classes of patents. A lot of those, half of those patents are more utility model patents, which are not the most innovative one. But still, you see the trend, right? I'll take another example, because of course you have the leader China, but I'll take the example of Singapore to show how a smaller country can play its own card and still play a role in AI. And Singapore is a good example where, of course, again, the magnitude of investment is different, but what you have to do is you have to focus, right, when you're smaller. And by being so small, it's something that makes sense for Singapore is to focus on smart city, because of course Singapore, that's 5 million people. The country is a city, so when the country decides to do a smart city initiative, then it's the whole, the cities, the countries, the whole country is behind it. Of course, the use cases are again matching the societal drivers that I've mentioned before, that are important for our nations. I think I want to skip some. You're seeing here the results. They're also very successful in deploying the AI and being seen as a most innovative city in Asia. And I would like to actually go faster and talk about what NVIDIA is doing. Okay. And so we can bridge to why we're here today. So remember the 3 pillars about AI national initiative. So you have infrastructure. You need to have application solutions, and then you need to be able to scale the population. And if you sort of double click on all of those 3 pillars, then you will run into more finer grained problems. And NVIDIA has actually programs that can help a country on its journey to AI, right? And myself, I'm representing actually a very small portion here which is the research collaboration, and which is why we're here in Modena and in Italy. So I'm part of the NVIDIA AI Technology Center, and that is actually a global program, actually an Asia-centric program. Again, Asia was started much earlier than we in adopting AI, and that concept was established in Asia and grew in Asia, and now is being imported to Europe. So I've opened a first center in Luxembourg, which was sort of our pilot center to see how we could localize the concept, because we're very different from Asia, and then within Europe, we're very different from one country to another. So it's going to be a learning experience for us at NVIDIA in bringing this concept of research collaboration into Europe, this concept of the AI Technology Center. And I'm very actually proud today to announce that that we've opened the collaboration in Italy. So Italy will be a big step up for us, because it's a much bigger country than Luxembourg. And so we've made an agreement with Chini, bringing some of the pieces that NVIDIA can help, and Unimore here will be sort of the first tangible collaboration with already a pilot project that is ongoing. When I talk about research collaboration, what do I mean? And there's you've seen there's many dimensions in which a country to actually become a player in AI. There's many aspects. There's the startup ecosystem, the education, the research, and in the research, where I belong, the problem that we're trying to help a country with, and it's not specific to Italy. It's really every nation is facing that problem. Is that the center of gravity for AI research, and when I talk about AI, I think that was also mentioned in the previous talk, is don't think AI research as basic AI, I'm inventing yet another neural network. It's also applying AI, because AI is a general purpose technology. The center of gravity for AI research has really shifted from the traditional academic players here to the large industry. And a reason for it is that we in academia have lower access to large infrastructure, big GPU clusters with scalable storage. And if you have less access to a tool that is critical for AI research, you develop also less expertise. On the contrary, the big industry players, including NVIDIA, Google, and the likes, and also Sony, we have this tool and we develop the expertise, so we can really scale our research. And you go to big conferences, and we already published a big portion of the leading research, right? And what we're trying to do here is by helping the researcher scale their research and use really the national infrastructure that actually are quite scalable, then we can get the research to upscale the research and lead more globally in the world. So this is what we will try to do here in Italy. This is going to be a journey. This is, I think, very exciting, and I'm really looking forward to doing more research in Italy. Do you want questions?
Yeah. Do you want?